I'm Anil Kumar, and in this video we will understand motion along a linear path and find rate of change of position. So as you know, rate of change of position is velocity. So we are discussing rate of change of position, right? So this is the example on rate of change of position, which indeed is velocity, right? So be clear, we are not talking about speed. We are talking about rate of change of position, which is always velocity, right? To start with, let me take up an equation and then we work on that particular equation. And let us say that the position s with respect to time is given by some formula, which is, let us say, 2t square minus, let's say 16, right? So let us say that is the formula for us to work with. And what we'll try to find here is what is the rate of change, average velocity of this object which is moving at any instance of time. So let's figure out so first part we'll find average velocity. So average velocity means average rate of change of position, right? So average rate of position, let's calculate a general formula when t equals to 3 and when t equals to, let us say, 3 plus h. Okay, so that is what we'll try to figure it out. So when t equals to 3, then the position will be s of 3, which is 2 times 3 square minus 16, and that is 9 minus 16, right? So let me write 9 times 2 is 18 minus 16, which is 2, right? So what we are assuming here is that the distance is in meters. So let me write down that this is 2 meters, right? So, and these units are in seconds. So time is in seconds and position st is in meters, right? So we'll give them a unit. Fine. So s of 3 will be, you substitute 3 here. 3 square is 9, 9 times 2 is 18, 18 minus 16 is 2 meters. Let us find what is the position after 3 plus h. So 3 plus h will be equals to 2 times 3 plus h whole square minus 16. We can now expand this. We get 2 times 3 square is 9 plus 6h plus h square minus 16, right? So which we can simplify. 9 times 2 is 18 plus 6 times 2 is 12h plus 2h square minus 16, right? So that gives us an expression which is 8 minus 16 is 2. So let me write down this value here itself, which is 2 plus 12h plus 2h square, correct? Now if we want average rate of change in this time, then the average velocity will be s of 3 plus h minus s of 3 divided by 3 plus h minus 3, correct? So that is the average velocity. So now from here we know what is s of 3 plus h, so we will substitute this value, which is 2 plus 12h plus 2h square, right? And s of 3 is, we calculated 2 meters, so minus 2 divided by 3 minus 3 is 0. You are left with h. So that is the average velocity for us. Now 2 minus 2 is 0, so we could simplify this. We get 12h plus 2h square over h, and we can take h common, right? So we could take 2 also common, but okay, that's fine. Let's take h common. So we get 12 plus 2h, right? So that is what we get over h. Now this could be further simplified, and so h and h cancel. So let me write down this as 12 plus 2h. So that is what we get as an expression for average velocity at between the time t equals to 3 and 3 plus h, correct? So that is the expression for this. Now if the question is to find instantaneous rate of change of position. If the question is find instantaneous rate of change of position, right? So that means we are talking about velocity. Is that okay? So instantaneous velocity. So in that case, what happens is that the h value approaches 0, correct? So when h value approaches 0, so we get velocity at t equals to 3, right? Exactly at 3. When h approaches 0, we get 12 plus 2 times 0, and that is equals to 12 meters per second. So that is how we could actually find instantaneous rate of change of position with velocity, right? So basically what we found here is that the average rate of change can become instantaneous rate of change if the time interval, which we are considering here, is very, very small when the limiting value of that difference in time is 0. So in that case, the average becomes instantaneous rate of change, as you can see from this example. Now, this example is extremely important to understand the concept. It is extremely simple example giving you a concept. So look at it very carefully and see how we did it, right? So initially, we found average velocity. So that means we are talking about 2 points. One point is when, so the 2 points are 3 and s of 3, right? So that is the first point. The other point is 3 plus h and s of 3 plus h. So when we consider these two different distinct points, then we find average velocity by difference quotient. So we had y2 minus y1 divided by x2 minus x1. Do you see that? So this is delta y over delta x, correct? That is difference quotient. So we got average rate of change in terms of the interval, difference in interval. But when you want to go for instantaneous rate of change, then you say limit h approaches 0, right? Then you get instantaneous rate of change, and that is how the two things are very much related. And I hope that helps you to understand the very basic concept. So let's move on from here and enjoy the journey of learning rates of change and moving on to calculus. Thank you and all the best.